The learning outcomes for this lesson would be describe a homologous series as a group of compounds with a general formula, similar chemical properties, and showing a graduation in physical properties as a result of increase in the size and mass of the molecules. For example, melting and boiling points, viscosity. Let's start with the definition of organic compound. Organic compounds, the compounds which contain carbon as an essential element. The exceptions are oxides, carbonates, and bicarbonates of carbon. For example, metal carbonates, they are not organic. Carbon dioxide, it's also not organic. Carbon monoxide, it is also not organic, although they contain carbon in them. Here are a few examples of some organic compounds from our daily life, like wood. This example of wood. It's an organic because this one contains carbon as an essential element. Coal. It is also organic because it also contains carbon as an essential element. Coal, wood. In all these, the carbon being essential, which means they all show typical properties of being organic, like on combustion, all will produce carbon dioxide, carbon dioxide, carbon monoxide, steam, along with some unburned carbon in the form of black or gray ash. Let's talk about hydrocarbons. Hydrocarbons are the compounds containing carbon and hydrogen only. These are some examples of hydrocarbons. You see, all these contains carbon and hydrogen. You see, in all of these compounds contain only two atoms: carbon, hydrogen, carbon, hydrogen, carbon, hydrogen. That's why they are called hydrocarbons. Functional group. The atom or group of atoms in an organic compound which govern their chemical properties. For example, in alkene, functional group is carbon-carbon double bond. And alcohols, the functional group is hydroxyl or OH. This is an example of alkene. This is an example of alcohol. Now I am circling it with green. These will be functional group in these compounds. Now let's talk about homologous series. A series of family where each successive member differs by CH2 group or 14 units. You can take example of any family. Here I am taking the example of alkane family. This is the first member of alkane. Now if I want to write the formula of second member of alkane, I will simply add CH2. I will get the second member. In this way, you can also predict the formula of the third member and so on. You can apply this rule to any other families. All the members of the family have same general formula, For example, alkanes have general formula CnH2n plus 2. This is the general formula of alkanes. Alkenes, the general formula is CnH2n. For alcohols, the general formula is CnH2n plus 1 OH. Chemical properties of all the members are very similar. For instance, alcohol on oxidation give carboxylic acids. Alcohols oxidation carboxylic acids. Alkenes on addition reaction with hydrogen give alkenes. Alkenes addition of hydrogen get alkenes. All the members of the family have same functional group. For instance, the functional group in alkenes is carbon-carbon double bond. The functional group in alcohol is OH. These are the functional group. All the members of the family can be prepared by similar methods. For example, alcohols can be prepared by the hydration of alkenes. Hydration of alkene means we are reacting alkenes with steam or water, will get alcohol. Carboxylic acids can be prepared by the oxidation of alcohols. Oxidation. Carboxylic acids. Members have gradual change in their physical properties like boiling point and melting point. As we go down the series, there's a gradual change, like there's gradual increase in boiling point in alkane family with increase in number of carbon atoms. See the table. This is the first member, methane. The boiling point is minus 164, and in the second member, which is ethane, the boiling point increases to minus 89. In the third member, which is propane, the boiling point increases to minus 42. In butane, the fourth member, it will be minus 1. In pentane, it's 36. This is because the molecule becomes larger. This is because the molecule becomes larger or increase in the size, increase in the size, the increase with the increase in carbon chain. And mass of the molecules and mass of the molecules. The intermolecular or van der Waals forces also get stronger. Forces also get stronger. Therefore, high amount of heat is required. Heat is required, or you can write needed, to break down the forces, to break down the forces. Lesson would be describe the alkanes as a homologous series of saturated hydrocarbons with the general formula CnH2n plus 2. First of all, I will talk about alkanes as a homologous series, which means all the members of the family differ by CH2 group or 14 units. We can predict the formula of the next incoming members by simply adding CH2. CH4 is the first member. You can easily predict the formula of the next member by adding CH2 in this way. The formula will be C2H6. All the members of the family have or follow same general formula, which is CnH2n plus 2. Let's take some examples. First of all, you have to learn the general formula for alkenes, which is CnH2n plus 2. CnH2n plus 2. This is a general formula. I have circled it with green. If you know the value of N, then you can work out the molecular formula of different alkane members. N represents number of carbon atoms in alkane molecule, which means it is a number. For instance, if the value of N is 1, then the molecular formula would be CH4. CH4. The name for this alkane is methane. It is widely used in cooking, heating, used in cooking, heating, CNG cars, etc. Methane is the first member of the alkane family. Let's work out the molecular formula of the second member of alkane. Here the value of N will be 2, so C will be 2, and in order to get the number of hydrogen atoms, we have to multiply 2 by 2. We will get 4. C2H4. We will then add 2. What we will get? We'll get H6. Therefore, the molecular formula will be C2 H6, it is ethane. Members have gradual change in their physical properties like boiling point and melting point as the number of carbon chain increases. For example, there's a gradual increase in boiling point of alkane family. You can see this table, the table showing first 5 members of alkanes, which are methane, ethane, propane, butane, and pentane. You see, as the carbon number increases or carbon chain increases, the boiling point is increasing. The boiling point first member is minus 164 degrees Celsius. The second member, it is minus 89 degrees Celsius. And in the same way, it increases. The pentane is the first member which exists in the liquid state at room temperature and pressure. Chemical properties of all the members are very similar. For instance, alkanes undergo substitution reaction with chlorine, bromine, and iodine in the presence of ultraviolet light. Substitution by halogens in alkanes. The reaction takes place in the presence of ultraviolet or diffused light. Diffused light is evenly distributed. Condition is diffused light. Diffused light is evenly distributed, leaving no sharp shadows. Lastly, all the members of the family can be prepared by the similar method. Now I will explain what saturated hydrocarbons are. Hydrocarbons which contain only carbon-carbon single covalent bonds or simply single bonds are called saturated hydrocarbons. We know that alkanes are hydrocarbons as they are made up of only hydrogen and carbon. What you have to remember is that they contain only carbon-carbon single bonds. Carbon-carbon single bonds. This is one of the member of alkane. Let me draw the other member. This is the third member of alkane. You see, it contains only carbon-carbon single bond. I have circled it with green. These are the carbon-carbon single bonds. Other organic compounds can also be saturated if they contain carbon-carbon single bonds. Let me show you some examples of other organic compounds being saturated. This is an example of alcohol. This is an example of carboxylic acid. Both are from different family, but they contain carbon-carbon single bond. Due to this reason, they are also counted as saturated organic compounds. Here the learning outcomes are pointing alkanes being saturated or containing carbon-carbon single bonds. Now let's see the formula of other members of alkanes. You see, it contains only carbon-carbon single covalent bond. It does not contain any kind of carbon-carbon double bond. This another member of alkane. It's also alkane. Again, you'll see it contains only carbon-carbon single bond. Draw the structures of branched and unbranched alkanes, C1 to C4, and name the unbranched alkanes, methane to butane. In my last lesson, I have talked about saturated and unsaturated hydrocarbons and organic compounds. I have also worked out to deduce the molecular formula of different members of alkane. In this lesson, I will show you how to draw the structures of branched and unbranched alkanes. Before proceeding, you should know that carbon belongs to group 4 of the periodic table, which means each atom of carbon is tetravalent. Tetravalent means an atom has valency of 4. A carbon atom in either hydrocarbons or organic compounds form only 4 covalent bonds. Now, alkanes follow general formula CnH2n plus 2. The molecular formula of first member is CH4. This is the molecular formula of first member. Formula shows that one carbon atom is bonded to 4 hydrogen atoms. We can represent the bond through single lines in this way. CnH2n plus 2, which means you will get CH4, methane, remember, each single line represents 2 electrons, that is one pair. These single lines represent 2 electrons, which means you have 2 electrons, which means one pair. Ethane, the second member, has a molecular formula of C2H6. C2H6. In ethane molecule, first of all, we will show how the bonding between 2 carbon atoms, that is through single bonds only. Recall, it is saturated hydrocarbon. This is ethane. You can see here that each carbon is forming 3 bonds with hydrogen atoms. 1, 2, 3. 1, 2, 3. I'm taking a pause so that you can try the third member of alkane family. The formula is C3H8. C3H8. In propane molecule, first of all, we will show the bonding between three carbon atoms. 1, 2, 3. That is through single bonds only. These are the single bonds. The displayed formula is of saturated hydrocarbons. Then I will show bonds of each carbon atoms with hydrogen atoms. 1, 2, 3. 1, 2. These are the hydrogen atoms. You can see that each carbon is forming 3 bonds with hydrogen atoms except the middle one. 1, 2, 3. 1, 2, 3. 1, 2. It will form bonds with only 2 other carbon atoms. The middle one is forming bond with 2 other carbon atoms. Try the fourth member of alkane with the value of N4. The formula will be C4H10. Here is the branched form of the fourth member of alkane. The learning outcomes for this lesson would be define isomerism and identify isomers. Draw the structures of branched and unbranched alkanes C1 to C4 and name the unbranched alkanes methane to butane. In this lesson, we'll see the concept of isomers as some molecules having different structures or structural formula, but they resemble in having same molecular formula. Carbon belongs to group 4 of the periodic table, which means each atom of carbon is tetravalent. Tetravalent means an atom has valency of 4. A carbon atom in either hydrocarbons or organic compounds form only 4 covalent bonds. When 2 or more compounds have same molecular formula but different structural formula, they are called isomers of each other. The phenomena is known as isomerism. Remember that carbon will form only 4 covalent bonds. It will neither form 3 bonds nor 5 bonds. Now let's talk about isomerism. In order to understand the concept of isomerism, consider this branch of Sepidilla tree. You can see further branching of this branch. These are the further branching. These will be circled as green. Other picture represent the branch of a Sepidilla tree without any further branching. This will be considered as a straight chain of carbon. Let me draw it. You see, it's like a straight chain of carbon. These two branches can be considered as isomers of each other. Isomers can be made from straight chain by removing and placing the end group in the middle of the chain. Now let's draw the displayed formula of first four members of alkane. We will start with methane. Recall the general formula of alkane, CnH2n plus 2. The formula is CH4. Its name is methane. The displayed formula would be like this. A carbon atom forming four covalent bonds with hydrogen atoms. It does not have any isomers. So let's write no isomer is possible. No isomer is possible. Now let's try the second member. The formula is C2H6. C2H6. The name is ethane. Again, I don't see any possibility of having isomer of ethane. So I will write again, no isomer is possible. For these two, isomers not possible. Same situation with the third member, that is propane. Formula is C3H8, name is propane. No isomer is possible. No isomer is possible. Let's check the fourth member. The formula is C4H10. C4H10. The straight formula for the straight chain would be like that. 1, 2, 3, 4. You can see each carbon is forming single bonds with hydrogen atoms beside their single bonds with other carbon atoms. These are the single bonds with hydrogen atoms. And it's also forming single bonds with other carbon atoms. Its name is butane. Let me write butane. Branching is possible here. It will be like that. There will be straight chain of 3 carbon atoms with a branching in the middle one. It will be like this: 1, 2, 3. We call this group as methyl. This is methyl group. It's called as methyl group. The general formula for alkyl group, it's coming from alkyl group, is CnH2n plus 1. This one is methyl. The value of n is 1. We'll get the CH3. This is CH3. The name will be 2-methyl propane. 1, 2, 3. This is straight chain. 2 methyl propane. You see the name is changed from butane because the straight chain will be of propane instead of butane. And a methyl group, this is the methyl group, will be attached. So this one, butane and methyl, 2-methyl butane, they both have same molecular formula. This is the molecular formula. They have same molecular formula, but different structures. That is, they are isomers of each other. So I will write here, isomer is possible. Is possible. Isomer is possible. The learning outcomes for this lesson would be describe the properties of alkanes exemplified by methane as being generally unreactive except in terms of burning and substitution by chlorine. Alkanes are generally unreactive because of strong carbon-carbon single covalent bonds. Alkanes undergo combustion reactions. Complete combustion of alkanes give carbon dioxide and steam or water along with heat. Incomplete combustion gives carbon monoxide and steam or water along with heat. Both complete and incomplete combustion reactions are examples of exothermic reactions, as heat is given off in these reactions, exothermic reactions. Complete combustion of alkanes. The word equation for the complete combustion of alkanes will be like this. The sign of delta H will be minus because the reaction is exothermic. I've taken the example of methane according to the learning outcome. So we have methane plus oxygen gives carbon dioxide plus water. As the reaction is exothermic, so we will write the sign of delta H minus. Let's write the symbol equation for this reaction. Methane is CH4 plus O2 gives CO2 plus H2O. Delta H is negative. Let's balance this equation. You see, only carbon atom is balanced on both sides of the reaction. Both hydrogen and oxygen are unbalanced in this equation. So I will write 2 before O2 and 2 before H2O. Now if we count the number of atoms, that is of carbon, hydrogen and oxygen, both of these are balanced on both sides of the equation. Incomplete combustion of alkanes. The word equation for the incomplete combustion of alkanes will be like this. Again, the sign of delta H will be negative because this reaction is also an example of exothermic reaction. I've taken the example of methane plus oxygen. Products will be carbon monoxide plus water. Sign of delta H is negative. Let's write the symbol equation for this reaction. CH4 plus O2 gives CO plus H2O. Delta H is negative. Again, carbon is balanced on both sides of the equation, but both hydrogen and oxygen are unbalanced on both sides of the equation. In order to balance the hydrogen, I will write 2 before water. Now the hydrogen is balanced on both sides of the equation. What about oxygen? On the reactant side, the number of oxygen atom is 2, but on the product side, it is 3. So I can write 3 by 2. Alternatively, we can also balance the equation in this way. CH4 plus O2 write 2 here. Instead of writing 3 by 2, we will write 6 here. We will write 2 here. Now we'll balance the hydrogen. It will be 4 H2O. Now you will see all the 3 atoms, that is carbon, hydrogen, and oxygen, are balanced in this equation. Delta H is negative. Alkanes undergo substitution reactions with halogens. We have chlorine, bromine, or iodine. In the presence of diffused sunlight or ultraviolet light. Diffused light is evenly distributed, leaving no sharp shadows. This substitution reaction is a type of photochemical reactions. Reactions that are catalyzed by light are called photochemical reactions. Now I'm going to show this substitution reaction by halogens in methane. I am taking chlorine here according to the learning outcome. Let's write the displayed formula of methane. And this one is chlorine. This chlorine will take this hydrogen, and this chlorine will make a bond with this carbon. So we will get chloromethane plus hydrogen chloride. Let me write their name. It's chloromethane. And this one is hydrogen chloride. The reaction will not stop here, and it will continue till all the hydrogens of alkanes will be replaced completely by chlorine. In the next step, the product of the first reaction will become the reactant. Another chlorine molecule will attack this chloromethane, and this time the products will be dichloromethane and hydrogen chloride. This hydrogen will be taken by this chlorine, and this chlorine will make a bond with this carbon atom. Products will be like this. plus HCl. It is dichloromethane. This one is hydrogen chloride. In the third step, again, the product of the second reaction will become reactant, one of the reactant. It will be attacked by another chlorine molecule. The products will be trichloromethane and hydrogen chloride. Trichloromethane, hydrogen chloride. The other name for trichloromethane is chloroform. In the past, chloroform is used to make patient unconscious before any major surgery. You'll notice one thing, that hydrogen chloride is the common product. It is produced in all these three steps. In the fourth step, tetrachloromethane is a product along with hydrogen chloride. So I will write with the product of the third reaction. Again, it will be attacked by another chlorine molecule. This chlorine will make a bond with carbon atom. Tetrachloromethane, hydrogen chloride. You see here, the hydrogen chloride is the most common product because it is produced in learning outcomes for this lesson would be describe a homologous series as a group of compounds with a general formula, similar chemical properties, and showing a gradation in physical properties as a result of increase in the size and mass of the molecules. For example, melting, boiling points, viscosity. Describe the alkanes as a homologous series of saturated hydrocarbons with the general formula CnH2n. Describe the properties of alkanes exemplified by methane as being generally unreactive except in terms of burning and substitution by chlorine. In this lesson, I'm going to solve past paper questions. So let's get started. Here's the first question. The alkanes are a homologous series of saturated hydrocarbons. Write the general formula for the alkane homologous series. So answer would be CnH2n plus 2. In the exam, they can ask any family. If they will ask about alkenes, you can write the general formula CnH2n H2N. For alcohols, it will be CnH2n plus 1 OH. The alkanes are homologous series of saturated hydrocarbons. Each member of a particular homologous series has the same general formula. Give one other characteristic of a homologous series. You can write any one of these responses. Any one from same functional group, similar chemical properties, you can even write react similarly. You can write trend in physical properties. You can write any trend like increase in boiling point, melting point. You can even write the definition of homologous series. Successive members differ by CH2. Successive members differ by CH2. Name all the combustion products of alkanes. Now in the question, they are asking about all the combustion products. They are not saying write the product for the complete combustion or incomplete combustion. Instead, they are saying name all the combustion products of alkanes. So it will be carbon dioxide, carbon monoxide, steam or water, and unburned carbon. Next question. Construct the equation for the complete combustion of pentane C5H12. Try to write the balanced chemical equation. Let's write the equation. C5H12 plus O2. Products will be CO2 plus H2O. If you look at the equation, all these three elements, that is carbon, hydrogen, and oxygen, are unbalanced. First, we will balance the carbon. Now, carbon is balanced. Then I will balance the hydrogen. Hydrogen is also balanced. There are 12 atoms of hydrogen on both sides of the equation. What about oxygen atom? 5 to the 10, 10 plus 6, 16. So I will write 8 here. Now it's balanced. Draw displayed formula and name any three substitution products of ethane by bromine. You can draw displayed formula and names of any three from the following substitution products of ethane by bromine. Here's one, HCl. This is a formula of ethane. I will replace one of the hydrogen by bromine. I am not showing hydrogen here. Here's another one. I will show the hydrogen now. Let's write their names. This one is hydrogen chloride. This one is bromoethane. This one is dibromoethane. This one is tribromoethane. I will continue writing the displayed formula and names. Last one will be like this. And all the hydrogen atoms will be replaced by bromine. Now let's write their name. Here we have 4 bromine. So I will write tetrabromoethane. Tetrabromoethane. This one is pentabromoethane. Pentabromoethane. The last one, hexabromo. There are 6 bromine atoms. Hexabromoethane. Chlorine reacts with pentane. This is the reaction. C5H12 Cl2 gives C5H11Cl plus HCl. What name is given to this type of chemical reaction? This is substitution reaction. What essential condition is needed for chlorine to react with pentane? It will be a light, or you can even write UV.